Welcome to Hormones and Neurotransmitters. Hormones and neurotransmitters are the mechanisms of how cells signal from one cell to another or one cell to a group of cells. Probably the most famous neurotransmitter is serotonin, but this is also the most misunderstood neurotransmitter. And probably the two top hormones that public would recognize would be cortisol and thyroid hormone. The two least known neurotransmitters would be adenosine triphosphate, that's ATP, and the interleukins, like interleukin 6. The whole point of signaling is to induce in the recipient cell or cells to react and do something, or to react and not do something. A good example is the neurotransmitter acetylcholine. So, for instance, in the sciatic nerve, the message going down from the spinal cord to the foot, the whole point of the signaling is to move a muscle. So acetylcholine tells a muscle to contract. But if it's the vagus nerve, then that tells a group of cells to reduce the inflammation. And it does this through acetylcholine. Another example would be interleukin 6. This is produced by the war room or the situation room in the brain, as most of the interleukins are. And it is a message to the periphery to activate inflammation for some particular purpose based on reconnaissance made by either the nervous system, like the vagus nerve, or the returning white cells. So one easy way to distinguish the two groups would be to say that the neurotransmitters work at close quarters, that is, very small distances like nanometers, whereas hormones work at long distances like centimeters or meters. One notable exception would be melatonin, which is both a hormone and a neurotransmitter, and it is the only fat-soluble neurotransmitter that we know of. And it can basically travel from the pineal gland in the brain to every cell in the body and sends a message to those cells, especially at nighttime. Sometimes hormones secreted by the brain need a holding bay before they can get into the general bloodstream. For instance, a part of the brain called the median eminence of the hypothalamus collects hormones produced by the pituitary gland, rather like a muster point. So it gathers people for an evacuation plan before releasing them. And one of the odd things about that part of the brain is that it's not behind the blood-brain barrier. And that term will come up again a few times as we do more on the nervous system neurotransmitters. Now, nerves can sometimes have intermediate stops as well. For instance, if you want to move your right big toe, it's actually the left side of your brain that sends messages down, and they have to cross from one side to another. So that's probably at least one stop. If you're thinking about flying to another country, it's not a non-stop flight. There's a hub in the middle that you have to stop at, and this has a couple of consequences. It means that both sets of nerves have to be running at optimal. There has to be minimal holdup in that hub or ganglion. So in general, nerves send their messages faster than hormones, but a hormone effect will last longer. That is, nanoseconds for nerves, maybe hours or days for hormones. And in this series, I'll alternate neurotransmitters and hormones in the series, and we'll cover the well-known ones, then work our way to the not so well-known ones. We'll cover the brain, the spinal cord, peripheral nervous system, autonomic nervous system, the enteric nervous system, the heart's nervous system, which is the intrinsic cardiac nervous system, and the vagus nerve. And probably some other things will turn up as we go. So I hope you enjoyed this, and we'll see you in the next podcast.